Thank you for inviting me for a second time. After I did my talk last year, it made me scratch my head a little what I should do now. But it has been a whole year, and yeah, we have developed some new things, or I've worked on some new things. So playing with local AI. This is when I was asked to figure out a talk, I had none of the stuff that I'm going to show you now. So I had to sort of guess what I was going to do the next year. I thought we were going to do programming with AI, with language models, but unfortunately that part isn't completed yet. So I'll focus on playing with AI, with image models and language models as part of an application and not as the development process. Because that is, of course, a very exciting future, is that we can integrate language models with programming. I mean, we all have seen Copilot, right? But as a builder of an IDE myself, I don't get to have free Microsoft tech like that. You can't just take Copilot and integrate it into your IDE freely. These are fairly closed systems, so this is also why the AI landscape as a founder is actually very challenging, because just like everybody's like, oh, I have Google Maps on my phone. Yeah, well, try to use Google Maps as a company and you'll find out that there are actually quite a lot of walls around these services, right? So these services level the playing field for all the consumers, but for all the companies, it's actually very hard. You're not just allowed to bolt onto OpenAI or whatever Microsoft makes with Copilot. And another difficulty is that they are heavily sponsoring the compute, right? Imagine you have a popular product and all of a sudden you have 100,000 users that want to use those GPUs. Hold on, we'll get in that later. So I'm building an IDE and we're working or looking at AI technology to enhance that. And I've been doing this now for 10 years. It's been a little while. I've tried it in JavaScript and now in Rust. And we rewrote the whole stack from scratch. So essentially I started at the platform layer with DirectX and OpenGL, that kind of stuff. Opening a window. And then build applications from there. But AI is moving incredibly fast, right? It is incredibly fast. It is almost, even when you're trying to play with it, it is moving so fast that by the time you have made your new toy, it's already out of date. So this is, for instance, let me see if I have that on my desktop. Wait. Too much stuff. Oh, here we go. So here you see a stack of computers, 6 computers, 6 4090s. I did this for somebody's birthday party, and he's like, you know, you have stuff. Can you do a fun little project? And I was like, scratch my head. I knew that Stable Diffusion, Stable Diffusion XL was just out, because Stable Diffusion is an image generator AI model, and I was never really excited by it. I thought the images were kind of bland. But then when SDXL came out, the images all of a sudden started becoming almost addictively breaking your brain, right? So I took 6 computers and I mapped it to a queue. You would type a prompt and it took 30 seconds for the first image to come out of the queue. But because we had 6, you could have a new 4K image every 5 seconds, right? So we sat down with the whole group of people and people started calling out words and things that we typed into. This is September last year. And it became this sort of group trip where, you know, the pictures were just so good. 4K, this is a cinema projector. So it was beautiful colors. And yeah, I noticed that the AI model was so good at generating images that people started to break. Their serotonin levels started to become erratic because the images were so good every single time. I don't know, it breaks people. It's not healthy. It's not a healthy thing. It's a trippy thing, though, to first experience that. But even now, like with all of this AI in the cloud available, I don't think a setup like this has been seen very much. But what I brought here today, this is my little computer here. It's, of course, the case is a little smaller because I was like, if I'm going to drag it around, I better make it smaller. So this is technically, I think, the smallest case you can cram a 4090 into. If you're curious about it, you come see it. It's really kind of a little miracle. I'm really amazed that it even fit. I'm not going to pull the cables right now to show you, but you can come after the talk and look at it. This is a little foldable HDMI screen, so I can see the Windows login and that kind of stuff. Because, of course, Macs don't have 4090s. They do have GPUs, and they are fast, but they're not as fast as a 4090. So I brought this time the same amount of speed, because the model was updated to go about 6 times faster, or not. It's a little like 4 times faster, but I made the resolution a little bit lower. So I did that thing at the birthday party, and everybody's like, whoa! And 2 months later, this was when AI was going a little slower, 2 months later, 6 times faster, right? It's just like, what? I could just chuck 5 of the 6 computers, and you'd have the same output. So this space moves so fast that in the olden days, you'd be like, oh, I made something nice. I'm sure it'll be nice in 2 months. In AI now. Now, even today, I brought something, and I just saw the news from MIT that they made it 10 times faster again. So I'm like, okay, well, next time you can run it on your laptop. I don't even have to bring a cool computer. What kind of models are we talking about here today? I'm not a machine learning expert. I just toy around with these things. But I do know a little bit. So we have large language models. I think everybody is familiar with those from GPT 3.5. 4, I'm not really sure what the architecture is. I should have looked it up. But Llama and Mistral are the open source models that are most famous. Llama comes out of Facebook, and Mistral is from a French company, the only European AI player that I know of. And then we have diffuser models, which is a text input, image output. Midjourney is one of those, stable diffusion from Stability AI, which is apparently very unstable right now. And DALL-E is from the OpenAI group. And these generate images by essentially a neural net trained on noise to an image. So they predict from the image what the noise is going to be, subtract the noise, and then do that in a loop. I'll show you a little bit of that later. So, and then lastly, there is the miraculous multimodal models, which are just about being released, where the AI model can actually see and hear. It can see images, it can reason logically from those images, and it can listen as well. These models are not as heavily represented in the open space, where you can just download it and run it, because they're, this is requiring a lot of compute and research. In a way, when OpenAI launched, if you would ask me 2 years ago, so how is this AI thing going to play out? I would have said, well, essentially you're SOL as an independent company, because all of the big models require vast amounts of data, which I don't have, vast amounts of compute, which I don't have, and then vast amounts of money to just even power the training sets, right? So how are you going to play in that game as an independent company? And another thing that I thought is, well, because it's an exponential process, right? The difference between 2 exponentials is, I think, an exponential as well. So that means that even if you're slightly offset from your open source models to the commercial models, eventually you're going to lose anyway, right? Because they just go faster and you just can't keep up. But strangely enough, with the release of the open models and Stability AI releasing SDXL, I found the gap with the commercial models not to be that large. It was really not as big as I thought it would be. So that means open source AI is actually surprisingly competitive and surprisingly interesting for the rest of us, essentially, who don't work for the couple of big AI companies to play with. And the fact that I can now here run that locally, to me, is a small miracle. 2 years ago, I would have said, like, no, that's never going to happen. And now here we are. So that's another example of, even if you're sort of in the environment, you think you know what's going on, it's incredibly hard to predict. So that's why when I see somebody predict things like, oh, in 3 years, I'm like, in 3 years? Really? You're going to do what in 3 years exactly? Well, in 3 years, this must be like this. Well, no. I think it's hard to predict 3 months into the future at this point in time. Yeah, it's really, really a crazy, crazy time. So let's build. Let's run this AI stuff locally. Let's make a generative image explorer. I showed you that I had a little previous version of that last time. Except what I noticed when we were doing this at the party is that the prompter, the person that has to type the prompts, it's extremely tedious. It's very hard. You have to have lots of imagination, and after a few beers, most people don't have a lot of imagination anymore. And it is also, to satisfy this need for new images all the time, you have to be very creative in the prompts. And you have to visualize what you want, and then the AI will generate it. But we also have language models, right? Why can't we just ask the language model, like, hey, figure something out, make it pretty, make it prettier, make it messier, whatever. But we needed a very good language model for that. And I think right now I'm using Mixtral, which is from Mistral, Mixtral 8x7b. That is an 8 times 7 billion model. I don't know exactly what the internal architecture is, but it is actually almost as good as what we see from OpenAI. It's ridiculously good. And why is local cool? Well, you can bring your own computer. I don't know, it used to be fun in the 90s. I still find it fun. It can actually be faster because you're not in a queue with some cloud where everybody wants the same stuff. And it has privacy, I mean, sort of. It's not connected to anything. This is a completely standalone network. So yeah, language model. As the image model, I'm using SDXL Turbo. This is the upgraded version from the original SDXL, using a new way to train the model on its own output to generate it faster. I was like, what? When that happened, like, okay. And it's really good. So how much compute did I bring here? I always like to keep tabs on how much compute you're using, because this also teaches you a lot about how much it costs if you would actually get this into a market, right? So that NVIDIA GPU, that's a 4090, it has 86 teraflops. There's 86, yeah. And it uses about 300 watts of energy for that 86 teraflops. And then GPU number 2 is the thing that I have here in my laptop, which is an Apple M3 Max. The cool thing about the Apple GPUs is that they use unified memory. And that means that you can get a very large amount of RAM. This one has 128 gigabytes. You can get 128 gigabytes of RAM onto a GPU that is actually only like 3 times slower than a 4090, and it sits in a laptop. So that means that you can load much larger models, right? The image models from Stable Diffusion are kind of geared towards people with their own game GPUs, so they can run sometimes in 11 gigs of RAM or 16 gigs of RAM. If you really push it, you can use the 24 that's in there. But 24 gigs of RAM is the hard limit currently for consumer-grade GPUs, right? So if you want more than 24 gigs of RAM in that GPU, instead of 2,000 euros, you're going to pay 20,000 euros for an H100 or A100 or whatever. The NVIDIA data center GPUs that have 48 or 80 gigs of RAM are obscenely expensive, right? These are not things you buy for fun. So this, the 4090, is actually, in terms of inference speed, just as fast as one of those 30,000 euro GPUs. So Apple hardware with the M3 is actually very competitive to run large language models, because the language models, this one that I'm going to run here is 40 gigabytes, so it wouldn't even run on this 4090. You can't even run that model. And the reason that you want a large, the large version of the model is accuracy, because the moment you start quantizing it, you can do quantization of the model. So instead of 16 bits, you made it 8 bits. Instead of 8 bits, you make it 4 bits, right? You can reduce the size of the model by quantizing. But then the model has the tendency of starting to spew garbage. It, very, very much more likely than the detailed model. So that means that this combination here is 114 teraflops. And just for a historical comparison, I know none of you were born at that time in 2005, but for me, you know, that was still a moment that, yeah, the second supercomputer in 2005 in the world, the Blue Gene something from IBM, with 41,000 cores using 0.5 megawatt of energy, was the same amount of compute as is now here. So, you know, that's a good, coming from a Commodore 64, that was a very fast computer, and now you have it here, right? So let's try it. We have, let's see, make that SDXL server. So you can ask, so instead of like having to painstakingly describe it, you can say, imagine a fantasy world in Utrecht. So now it's thinking. It's actually streaming, but I didn't feel like implementing streaming yesterday. I only had it, it's only a day old. And it's fast enough that, hold on, I have to turn on render. There we go. Oh, it's kind of, oh wait. So it's actually blending in, it's actually blending in the camera, as you can see. So, yeah, so the image model is, I mean, it figured out that there's people in the picture, but it will not look like you. It is probably also very sexist. Everybody's got beards. This is, by the way, a great party trick to point a camera and a prompt machine at. I'll isolate you from the feedback loop. But what is really cool now that you have these two inputs, right here is like a mystical castle. So this is the prompt that goes into the language model directly. If you edit this, you have to just type it out. But here you can say, all right, here you can say, magical creatures, beautiful city of Utrecht, make Utrecht Amsterdam. Oh. What was that? Oh, did I kill it? Oh no. Here we go. Let's see, imagine magical fantasy land with, well, gremlins. So there we go. And then we render. There we go. So now it says mischievous gremlins, which I don't actually see. So where are the gremlins? Maybe it doesn't know what gremlins are. So make the gremlins elves, please. And now it will rewrite the prompt by changing gremlins out to elves, which should happen. There we go. So instead of now, and now you can say, make it more psychedelic. And there we go. Now it's going to be more psychedelic. Yeah, I mean, I was also like, wow, okay, you know, this is available to anyone with enough computing power, and you can just install it, run it locally. Of course, this UI is the thing that I made for this interface, so that it's easy and fun to interact with. Because that's one thing that I noticed, that the UIs that are around the AI is where at least there's some opportunity left for humans to make the workflow nicer, right? And so make it weirder. Let's see what it does. Is it getting weirder? Oh, it's getting dark now. Too dark. Make it brighter and colorful. Maybe he doesn't like the English spelling of colorful. It's surprisingly resilient to spelling errors also. So the way this works is... oh wow, that looks totally not at all like what I was expecting. Okay, make it simpler. It's shorter. See, now it produced a whole blob of text. And you notice now that the image model is completely lost because there's LED in the text, and that has such a strong weight to it that the whole fairy tale thing just stops working. Let's see what it's doing. Oh, that's not shorter. It's not listening to me. I maybe have to punish it. Uh-oh, uh-oh, uh-oh. 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 Yeah, I do have to say this model is unrestricted. If I make a typo, then yeah, you have to cut it out of the video then. Yeah. Anyway. Here we go. These are some of the other experiments. This is also great fun with your kid, by the way. I call this Imagineering with my son, and we just surf the AI waves, and he says like, yeah, can the cat do this? Can it do that? And the problem with this image model is that it's not really good at following the prompt. So it's sort of like it pulls some keywords and some sentences out of the text, and then makes an image out of this. But the new model, Stable Diffusion 3.0, does have very good prompt following. You can say this person in front of that, next to that, with this there and that there, and it can do it. So I was very sad to hear that the CEO of Stable Diffusion left, of Stability AI, because he is the guy that is pulling this into the open. Because for the venture firms that are behind these companies, having these models open is really not that good of a business decision, right? You should gate this, put this in the cloud, gate it, put a subscription model on it, and then people can use it. And it was the CEO that was, and the founder that was like, no, we shall make these models open. This is why this is now usable here. Let's see. Make everything Legos. Imagine a Lego world with astronauts. I know now why it actually crashes, by the way. It's when I type a backslash. And then my JSON goes. Yeah, see. What is it? Sanitize your inputs, was it? Yeah. Here we go. Let's do some Legos. Legos are always safe. Legos are safe. It's very hard to go wrong with Legos. Okay, and so the images are generated. And what are the parameters, right? What are the parameters to this image? The image models actually have to run a number of steps to converge to an output image. In this case, it used to be that Stable Diffusion took 30 steps or something to converge to a nice image. But with this turbo model, it actually converges in 10. And apparently MIT just made something that converges in 1 step. So that would already be almost 10 times faster than this. So yeah, it goes to 8, now it's almost recognizable, and then at 10, I find it almost perfect. But you can see it goes slower. And you also have random noise as input. In this case, if I turn on random, you will see that this scene will start to become something else, completely different. And the denoise is, what was it again? You have the input image, right, that I'm using from the camera. It turns that into a latent space, and then it adds an amount of noise. And if you add 1.0 noise, then there is nothing left of the input image. But if you add it half, then it will put Lego astronauts in the sky over everybody. And so you can sort of play with how weird the reality of the model is. And I found that I put this situation, this setup, I put in a gallery once for fun. So like, hey, because when you do this for people, all of a sudden they're like, whoa, can you do it at my party too? Like, well, maybe once for old time's sake. But I found that the most use that people did was to turn themselves into celebrity pictures. I was like, really? You give them the universe, and they want to look like Brad Pitt. I'm like, okay. The context of the prompt, so the language model is stateless, just like the image model, right? Everything that you put in determines what comes out. It doesn't have a memory. The memory you provide in terms of the prompt or the context. And this is also how language models do that, because like, how can you have a conversation with that? Well, actually, you give the whole conversation to the AI with an extra message added on to the end, right? And that also means that the longer the conversation, the more context needs to be encoded onto the GPU. And context, 10 minuten? Wow, I'm not even... Okay, let's see where I was. Yeah, well, okay. So it's a stateless thing that you provide all the context for. And for the language model, that means that here I'm building up, essentially. That's why you also saw it go slower. And I think when it flipped out, I probably went over the size of the context window, and then, you know, all bets are off. So you need to keep in mind how much context you can put into the language model. This is also why I made the trim function. The trim function essentially deletes all the questions except for the last answer and the last quote, so that you can have a fresh context, because otherwise it'll just freak out. And for the image model, this is actually really cool. This is called Comfy UI. I didn't write this, but Comfy UI allows you to design a flow graph, a visual flow graph, for the image model behind it. And this has created a tremendous creative boom, because you can do all sorts of things with these neural latent images, these data structures that are propagating through the GPU. If you just say, hey, stop halfway and do the other half with another neural network, right? You can just do that with this kind of composition. And here you see this is really the engine that I'm just replacing a little string in a giant JSON file, and I'm throwing it to the backend engine of this of Comfy UI. So yeah, if you're interested in playing with Stable Diffusion, I think Comfy UI is a beautiful system. So yeah, that's the flow graph that's behind that. The language model is running on Llama CPP. You can also just git clone, make, and it runs. You download from Hugging Face, you download the language model, and off you go. So, well, I guess that's then the closing remarks. Go play locally. I'm thinking of putting this somewhere maybe, but maybe also not. It's very dangerous to put open, unprotected models in a public space, I've found. Especially when young, drunk males are involved. Anyway, thank you for your time.